Hey guys, we're going to go over the hypotenuse leg congruence theorem today. Okay, this is a congruence theorem that is a special congruence theorem. It only works for right triangles. So if you read the theorem, it says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. So this can only be used with right triangles. It cannot be used with acute or obtuse. It must be a right triangle. So if I look at the diagram down here, I see that I have a right triangle here because triangle ABC has a right angle, an angle B, and then also triangle DEF has a right angle down here. So I could potentially apply this theorem. Let's go ahead and check if I have a hypotenuse, a set of hypotenuse congruent. So I see AC, this side over here, is the hypotenuse. And over here, DF, this is the hypotenuse for this triangle. So it looks like those are marked congruent for me. I also have down here, I have this side, BC, which is a leg because it's connected to the right angle. And over in the second triangle, I have EF, which is another leg. So I do have hypotenuse leg in both of the triangles. Therefore, I could say that the two triangles are congruent. Okay, triangle ABC is congruent to triangle DEF. All right, now that's the basics of the theorem. Let's go ahead and look at some examples. Now, in these examples, it wants us to say whether or not the two triangles are congruent, okay? If so, state the postulate or theorem that we used. So remember, we have some previous postulates and theorems that we learned. We learned about angle, angle, side. We learned about angle, side, angle. We also learned about side, 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 and side angle, side. So any of these are fair game, okay? But we're also going to throw in our new theorem that is only good for right triangles, which is hypotenuse leg. So let's go ahead and let's take a look at these examples, all right? On the first problem, I see that I have two right triangles. I'm going to check if hypotenuse leg will work. When I'm looking at this side over here, I know it is a cross from the 90-degree sign, so this must be a hypotenuse. Also, when I look at the second triangle, I see this side, CD, is across from angle E, so that must also be a hypotenuse there. Now, let's look for a leg. I see that I have a side attached to the right angle. That would be a leg there. And over here, I'd have another side attached over here, so that would be a leg. So we do have hypotenuse leg congruence. Let's go ahead and answer the question. So yes, triangle, we'll call the first one ABC, is congruent to triangle. If I call this one ABC, I have to call the second one EDC to be in my corresponding order correctly. Okay, by HL. All right, let's go ahead and look at the second problem, okay? In the second problem, I see that I have two angles already marked, so that's nice, okay? What I do notice is that they're not right angles. There's not any right angles in this problem at all, so I'm automatically going to rule out hypotenuse leg and look at the first four that I know, okay? I'm probably not going to use side, side, side because that doesn't have any angles in it, so I'll be using one of those three. Let's go ahead and see that I have these marks here, okay? These are not congruent marks, those are parallel line marks. So when I have parallel lines, what I'm going to look for is I'm going to look for alternate interior angles. I know that alternate interior angles are always congruent. So I know between these two parallel lines, these two angles that I'm marking are alternate interior. I'm going to go ahead and mark those congruent. Now, right now I only have two angles. I need something else. So one thing that I like to look for is alternate interior angles. I like to look for vertical angles. I don't see any of those. But what I do also look for is a common side. I see that these two triangles are sharing this side, therefore this side can be marked congruent to itself, okay? So now when I'm looking at this, I have an angle. I have an angle and I have a side in this triangle. In the other triangle, I have an angle. I have an angle and I have a side in this triangle. So yes, they are congruent, okay? And I'm gonna list their order. So let's call this top triangle, triangle RSU. It's congruent to triangle. If I called it RSU, remember I started with one mark here. I'm gonna have to start with one mark here. I'm gonna go TUS. And this would be congruent by angle, angle, side. All right, let's go ahead and look at the last one. I see that I have a right triangle there. However, let's look at what we have, okay? We have marked a right triangle on both. This one here is a leg, okay? Now, the other one that's already marked for me, here and here, this one's also attached to the right triangle. It's a leg, okay? So far, I just have two legs. Now I'm gonna look at, they do have a common side. So now that can be congruent to itself. That's a hypotenuse. So I'm gonna go ahead and say, yes, these are congruent by hypotenuse leg and write my congruent statement. So yes, triangle, let's call this first one JML. Is congruent to triangle. And if we call this one JML, let's call the other one LKJ. And they are congruent by, we could use hypotenuse leg. Now, some of you might have thought, well, we didn't even need to label this hypotenuse. We could have said this was side, angle, side in both triangles, and you could have proved it congruent by side, angle, side as well. So this one you had two different options. You could have also done by side, angle, side. All right, let's go ahead and let's take a look at the last problems. Okay, so set B, it says tell whether the theorem or postulate can be used to show that triangle LMN is congruent to triangle QMP. Okay, so we're going to go ahead and look at each individual theorem and see if it works. Now, before we start looking, I want to label anything else in this diagram congruent that may be unmarked. So I do see that I have vertical angles here, so I'm going to label these two vertical angles congruent. So now that I've done that, let's go ahead and look at each particular theorem. Angle, side, angle. Well, if I'm looking, I do see that I've got an angle, a side, and an angle in this one. And I have the same thing over here, angle, side, angle there. So I could say, yes, angle, side, angle works. Okay, let's go ahead and let's take a look at the next theorem. The next theorem says angle, angle, side. So do I have two angles in a row and then a side? Let's check. I have an angle here, I have an angle here, and I have a non-included side over here. So angle, angle, side. Let's look at the other triangle. Angle, angle, side. That works in the other triangle as well. So yes, angle, angle, side is working as well. Okay, let's go ahead and let's take a look at the number 3, hypotenuse leg. Okay, so I see that I do not have the hypotenuse marked. And the hypotenuse is not a common side because these two triangles are not back to back. Okay, so I cannot use hypotenuse leg here. So this one is a no. Okay, if you look at where the hypotenuse is here and here. There's no markings there that are showing me that those two sides are congruent. Okay, so I can't use hypotenuse leg on this particular triangle. All right, let's look at the last one. The last one is side, side, side. Okay, again, I have two sides marked, a side, and over here a side and a side, but is the third side marked? No, it's missing. So that one's going to be a no. All right, guys, that's all for today. Give the homework a try. Good luck.